Hi guys, my name is Ian, and this week I'm back with my solution to lesson number 14 in Paul McWhorter's Arduino with Python series. We had to model a moving marble in a room using parameters. Now, I did that last week, so this week I've done something different. Let's have a look at some code. So, what have I done this week? Well, I still have boxes and I still have moving marbles, but what I am doing is I'm having two boxes and I'm linking them with effectively another box, but I'm calling it a tunnel to emphasize that it's not a box in its own right with a marble in its own right. So I've got a top box and a bottom box and a box linking the boxes. Excellent. So this is the box code, and it's what we saw last week. It's I've only changed it to well, height, width and depth was started to confuse me, so I've converted it all to X, Y and Z. Made far more sense. So that's that. We've got a very similar function drawing this tunnel, and effectively it's a box without a top and a bottom, because the top and bottom is going to be the bottom and top of the other two boxes. You will see it in a minute. It's very important that it's all parameterized, because the size of the tunnel has to be so that it actually touches the two boxes. We can't have a space between them. They have to touch. They have to have a joint perimeter where they share basically a wall. In my case, it's a wall of infinite thinness. There's no wall really, it's just a point in space. Now, this bit here is important. I will get to that in a minute, because this is a cheat. I had to cheat. Now, what are we doing? Well, we've got two boxes and we want a ball to move between them. What we need to know is where the ball is. So in this case it's ball 1, which starts in box 1. What I do is I work out where ball 1 is. Is it still in box 1? Is it actually in the box 2? Or is it in the tunnel? Now, depending on where I work it out, and the working out is simply where is it compared to the perimeter of the shape that it's supposed to be in. Now, depending where I work it out, I set a single bounds, basically making it equal to arena 1, arena 2 or the tunnel, depending upon where I find ball 1 to be. I do the same for ball 2. Same code, it's just talking about ball 2 instead. Note these things. We will get to that in a moment. Next thing we do is we want to move the ball. So we've already worked out where it's going to be going to, because that's what this is doing. It's working out where the ball is going to go to. So when it goes there, we already know where it is, and it's in bounds, whatever we worked out bounds to be. And then this is simply the perimeter finding code, which reverses the direction of the ball. Again, I'm ignoring radius for the moment. Very important, I will get that in a minute. I do the same for ball 2. So we've got two balls, each moving independently. One starts in the top, one starts in the bottom, and they've got a connecting tunnel, and they can move between them. Now, why have I talked about this radius so much, yet the ball doesn't have one? Well, actually the ball did have one, because I had to make it a certain size to make it so that we could see it. But what I found was that all this code is effectively trying to keep the ball from escaping a box. Now, to get into another box, it's effectively what I want to do. I want it to escape. And that's when things start getting difficult, because depending upon what the direction of the ball is, when you take into account the radius, you need to add it or subtract it from whatever you're doing. And unfortunately, I still haven't got my head around exactly how to do that sort of adding and subtracting when it's moving from one box to another, because the code is all assumed. There's a big assumption we're making in this code, and the assumption is there's no jailbreaks, but we are allowing jailbreaks, so that's when the logic starts to fall apart. Until I decided try it without having a radius. Now, there is a side effect of not having a radius of the ball. It does mean when it bounces off a wall, it's the center of the ball that bounces. Therefore, sometimes you see the ball, its radius coming through the wall, but it still bounces. And more importantly, until I get my head around the allowing escape code when the ball does have a radius, this is how it works. So, summarize the code again. We got 2 boxes getting drawn with this code. We have a tunnel being drawn with this code, and the tunnel is suitably sized so that it does link the 2 boxes together. And then we have location detecting code for ball 1, location detecting code for ball 2. That helps us work out where we are, the bounds of the box that we're in. And then we have we've just hit the wall. Let's reverse direction in whatever axis of whatever wall we've hit. Ball 1, ball 2. Now, let's run this and see. It's nearly there. Let's switch over so you can see something. And here we have it. We've got 2 balls bouncing around. There's one, the green one's already escaped, and it's into the other box. They both start with random positions, random vectors. So they move totally different to each other. It might well be that blue ball doesn't escape for a long time. The green ball can be maybe escape several times. Who knows? But there we have it. We've got code, 2 bouncing balls, and with a bit of luck we might see the blue ball escape. Oh, we're so close. Oh, the green ball's back. There we go. And that's it. If you do notice the on the bounces, when it hits a wall, you might see the radius of the ball coming through the wall. And we'll get my head around that radius code in the next week or so. Anyway, there we go. Any comments, leave them in the boxes below, and as usual this code and a wee picture will be on GitHub for you to download and experiment with yourself. Until next week guys, thank you.